Good afternoon again. Today we're going to start talking about the information in Chapter 6, which is on atoms, ions, and periodicity. If you remember, we've already taught some about atoms and the elements on the periodic table. And in Section 6.1, it continues that conversation of atoms and those elements on the periodic table. It suggests that you memorize the information for the first 20 atoms on the periodic table and for those elements that are listed in the first two columns of the periodic table. And so it wants you to know their symbols and where they are and their atomic number. And again, I don't really think you need to memorize them. I do think you need to be familiar with how to use the periodic table, though. So please make sure that you are aware of where this information is located on the periodic table and how to use the periodic table to help you with that information. In section 6.2, it moves on to talk about the terms that are associated with atoms. The first one being you need to know what matter is. And please remember that matter is anything that has mass and takes up space. When we talk about electric charge, we're talking about either a positive or a negative. And please remember the rules that like charges repel each other, they push away from each other, and unlike charges attract. So if you think about with a magnet, if you have the North Pole and the South Pole, they will attract to one another. But if you try to put two North Poles together or two South Poles together, they will push away from one another. That's repulsion. The third term that you need to be familiar with is atom. And again, you find all the atoms that exist on Earth on the periodic table. We are currently aware of the first 118 atoms that are available to us on Earth. They are still researching other atoms. They may find additional ones. But please remember when you write their symbols, with their symbols, the first letter of the symbol is capitalized and the other letters are lowercase. So when you write these atoms, please make sure that you write their symbols properly. The fourth term that you need to be familiar with is the atomic structure. And so we're talking about the subatomic particles that are present in atoms. We're talking about the protons, the neutrons, and the electrons. Please remember that your protons and your neutrons are found inside the atom in the nucleus. Your protons are your positively charged species, and they are represented by a P with a plus sign. Remember that your protons have a positive charge, a 1 plus charge to be exact. They have a mass of about 1 AMU. They are found in the nucleus. They are used to represent the atomic number of the atom. The atomic number tells you how many protons there are in any particular atom. And the number of protons is also what determines the name of your element and the symbol. And you never change the atomic number by a chemical reaction. So chemical reactions do not involve changes of protons. When we move to neutrons, we're talking about the neutrally charged species that's found in the nucleus. It has no charge, positive or negative. It has a mass that's about equal to that of a proton, being 1 AMU. Again, it's found in the nucleus with the protons. They actually are used to hold the protons together. And so, again, neutrons in a chemical reaction are neither gained or lost. And so for most elements, the neutrons don't play a major role in the atomic structure of that element. The third subatomic particle is your electron, and we represent the electron using an E with a negative sign. And remember that your electron is not found in the nucleus. It's actually found outside of the nucleus. Each electron has a 1 negative charge, so it is the same amount of charge as a proton, but it's exactly opposite in its electrical charge. Okay, neutrons have very little mass, and so when we consider the mass of an element, we actually don't use the electrons at all to determine the mass. We just add the protons and the neutrons. Electrons are again found outside the nucleus. They actually live in the electron cloud, and the specific location of their houses is called the orbital. So electrons live in orbitals that are outside the nucleus. And so what we actually find is that most of the volume of the atom is in the electron cloud. The nucleus is very small and at the center of the atom. But for electrons, they are what are gained or lost in a chemical reaction. So as we start talking about chemical reactions, you'll see how electrons being gained or lost is what actually motivates a chemical reaction to take place. Now, the next term that's mentioned in your book is neutral atoms. And again, we're talking about atoms that don't have a charge. And why don't these things have a charge? Well, they don't have a charge because atoms have the same number of protons and electrons. So their positive charges and their negative charges balance one another out. And so atoms are electrically neutral. All right. The next term that is introduced to you in this term section is your ions. And ions are actually atoms that have charges. Once an atom has a charge, we don't call it an atom anymore. We actually call it an ion. Well, how does an atom get a charge? The answer is I gain or I lose electrons. So if I gain electrons, then I get a negative charge because electrons are negatively charged. And so I've added to the number of negatives that I have. And now my negatives outweigh my positives. That's why gaining electrons produces a negative ion. And we call a negative ion an anion. Or if I don't gain electrons, I can lose electrons. And when I lose electrons, now I have more positive charges than I have negative charges. And so my overall ion would be positively charged. And we call positively charged ions cations. So when we want to determine what the charge is on an ion, all we have to do is take the number of protons we have and subtract the number of electrons we have, and that will determine what our net charge is on our ion. Now, your book also gives you several examples of what happens. So it gives you the examples of sulfur, which we know is a nonmetal, and we know that nonmetals gain electrons. It also gives you an example of potassium, which we know is a metal, and we know that metals gain electrons. Metals lose electrons. So metals have your positive charges and your nonmetals get your negative charges. And then you have several examples to practice with those concepts there. In section 6.3, that's where we move to talking about the nucleus and how small it is compared to the rest of the atom. It then moves on to talk about the different kinds of nuclei you can have. And again, nuclei is the plural of nucleus. You can have nuclei that are stable, that are radioactive, or that are unstable. Stable means that it does not change. It has not changed on Earth in billions of years. When we go to our radioactive nuclei, they are somewhat stable, but they actually decay and form new atoms altogether. So now you've got a loss of protons and neutrons. So you actually form a new element when you have a radioactive decay of an atom. And then you've got unstable nuclei, which when they form, they decay within a few seconds. So they really don't stay together at all because they are unstable. And so your book then moves into that terminology with nuclide and talking about isotopes and how you represent nuclides and isotopes. It also talks about how you find your mass number. And again, remember, for your mass number, you add your protons and your neutrons, which are both found in the nucleus of your atom. It gives you several examples of the symbols that you need to use for nuclides or isotopic symbols, and how you write those. Then your book moves into finding the mass of a nuclide. And remember, you use the atomic mass unit as the unit for that. And again, they have to tell you what isotope of the particular atom that you're looking at in order for you to come up with the correct mass. So you will either have to know the mass of the isotope, or you'll have to know how many neutrons the isotope has to correctly determine the mass. Please remember that that mass that is given on the periodic table is not the mass number. I repeat, that mass that's given on the periodic table is not the mass number. That mass that's on the periodic table is the atomic mass, and it actually is a weighted average. And so you will actually have to know all of the isotopes of an atom that exist in order to find the weighted average to get that mass that's on the periodic table. And then your book moves into talking about isotopes in chemistry and how isotopes were discovered and what role they play in chemistry currently. And then in section 6.4, we move into talking about elements and compounds. And so that's where you're introduced to terms like substances, what chemical formulas are, the different phases or states of matter, your solid, your liquid, or your gases, what are molecules, what do formula units represent. You've got your elemental states, which at room temperature, what state of matter are the elements that are on the periodic table. They then introduce the term monatomic elements, mon meaning one, so one atom elements, and they give you examples of that, and they talk about chemical bonding with polyatomic elements or diatomic elements, those elements that in nature never exist by themselves. They always come with a partner. You can remember those as the Han halogens, Han being HON for hydrogen, oxygen, nitrogen, and then your halogens, those elements in column 17. Again, in nature, they never come by themselves. They will always have a partner. And so when you see something that says hydrogen gas, that's H2 and not just H. And that 2 is a subscript that tells you how many of those elements are in that particular molecule. Then you talk about metal atoms and how they are malleable. You talk about compounds and what compounds actually are and what molecular compounds are. Most of the compounds you'll deal with will be ionic in nature, and we'll talk a little more about what it means to be ionic. But when we move to molecular compounds are covalent in nature, so you're sharing electrons instead of giving and taking electrons as you do in ionic bonds. And then your book moves into talking about molecular formulas. It also talks about your structural formulas and again your ionic and the ionic compound formulas. It also talks about empirical formulas and standard formulas, and when you write formulas, how you need to write those. And then in the very last section in this chapter, you start talking more about the periodic table and how that periodic table is organized, how you have your rows that are called periods and your columns that are called groups, how you've got your different group names, like your main group elements for your group A elements, or your transitional elements for your group B elements, and how you have those last 2 rows that are at the bottom of the periodic table known as your inner transition elements. And then your book goes into more specific detail about the family names for the groups that are on the periodic table. Next, your book goes into predicting behavior of elements based off of where they are located, and talks about your different classification of elements, your metals, your nonmetals, your metalloids, and the properties of those. Then you'll find your review quiz on page 119, and you'll also find the answers to that review quiz on page 122. As you're reading through this chapter, if you have any questions on anything, please always feel free to reach out. I do have virtual office hours that you can contact me if you are unavailable to come to campus. You can always email me, call me, or text me. I am available anytime you need me. Please, please, please make sure that you're looking at your due date calendar to know when your assignments are due so that you don't miss any of those due dates. And y'all, please don't procrastinate. I hope you have a good rest of your week. Thank you so much. And I look forward to seeing you at our next Collaborate meeting.